Good morning, students. This is the class chemistry class AS Unit 1. Look, this is the learning objectives. Today we learn these things. Understand the effect of ionic radius and ionic charge on the strength of ionic bonding. Then we will understand how ionic radius and ionic charge effect on the strength of ionic bonding. Then we will understand the reasons for the trend in ionic radii down a group in the periodic table for set of isoelectronic ions from this one to this one. Understand the meaning of the term polarization as applied to ions. Polarization. Okay, look at trend in ionic radius. Radius singular, radii plural. So plural is it will be radii. Look, this group 1 elements, group 1 sodium, lithium, sodium, potassium, rubidium. This group 1 elements, electronic configuration, lithium, sodium 2, sodium it is 1 electron loss, it is lithium 3 electrons, so 1 electron loss, so 2 electron. Sodium 11 electron, 1 electron. It when sodium atom it was 11 atom electron 281. When it lost 1 electron it becomes 1 positive charge, so 28. And ionic radius is 0.012, potassium 0.138, rubidium 0.0152. So ionic radius in a group increases. Okay, look, increases ionic radius from 0.076 to 0.152. In a group like group 7 element, fluorine, chlorine, bromine, iodine, astatine, this ionic radius down a group increases from 0.133 to 0.220. So ionic radius increases. Why? As the down a group ionic radius increases as down a group number of shell increases. Look at, as you go down each group the ions have more electron shell. As you go down the group ions have more electron shell, therefore ions get larger. Okay, next is in a period. You know group and period. Period like this, the period 2 elements. Period 2 elements, nitrogen, oxygen, fluorine. Okay, number of electrons, electronic configuration. Number of protons 7, 8, 9, but electrons are same. Look, this nitrogen, oxygen, fluorine. This one nitrogen, oxygen, fluorine. Okay, it means N3 means nitrogen, just nitrogen. We know atomic number is 7. Nitrogen 3 minus means it gain 3 electron. So proton number is 7, but electron number is 10. Okay, here proton number, we know oxygen atom 8 electron, but it gained 2 electrons, so 10. So electron number here also 10 and proton number 8. Fluorine, we know 9 fluorine atom. This fluorine atom we know 9 electron, atomic number 9, so electron 9. It gained 1 electron, so electron number 10 and fluorine proton number 9 remains same. So proton number 7, 8, 9, electron number 10, 10, 10. So what will be electronic configuration? It will be 2, 8, 2, 8, 2, 8, 2, 8. So electronic configuration 2, 8, 2, 8, 2, 8. So number of protons is nitrogen 7, nitrogen ion 3 is 7, it's 8, it's 9, and electronic configuration, as all are same number of electrons, 10 10 10, so they are isoelectronic. When the electronic configuration are same of the elements, atoms, they are called isoelectronics, because these elements have same number of electronic configuration, same number of electrons. Look this from left to right. Ionic radius 0.146, 0.140, 0.133. Ionic radius decreases in a period from left to right. Ionic radius decreases in a period left to right. Ionic radius decreases. Why this is? The number of protons, so we know sodium at electronic configuration, sodium electronic configuration, sodium, then which are sodium, magnesium, aluminum, sodium, magnesium, aluminum. Sodium, what is sodium? Sodium electron number, atomic number. Sodium is 11. When it it lost one electron, so electron number become 10. Here magnesium 12 electron, it 2 positive means 2 electron lost, so 10 electrons. Aluminum 13 electron, we know aluminum atom 13. Aluminum 3 plus means lost 3 electrons, so 10 electrons. So their electronic configuration will be 2 8 2 8 2 8 2 8. So electronic configuration are same, so they are isoelectronic. Sodium ion, magnesium ion, aluminum 3 ion, magnesium 2 plus ion, sodium 1 plus ion, they are isoelectronic. How many proton number? Proton number and remains same. Proton number 11, and it is 12, this 13. But here electron number changes. Are you listening me? Something internet problem. The look, it is showing connecting. Are you listening me? Okay, I have a question. I have given a question to you. Write the formula of an ion from period 3 that is isoelectronic with chloride ion. Okay, you write a formula of an ion that is from period 3. It will be period 3. You will choose any elements from period 3 elements, and it's the isoelectronic with chloride ion. This is the chloride ion Cl minus. Okay, write and submit to my or you can say to me what will be isoelectronic of chloride ion from period 3. Which elements are period 3? Which are pure 3 elements, like sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Okay, they are pure 3 elements. Write an ion atom Write an ion of isoelectronic with chloride ion from period 3. What are you doing, student? You can say to me or type isoelectronic. How many electrons here? Chloride. Chloride. How many electrons here? Chloride. Chloride ion. How many electrons? Are you submitting?
Yes, sir.
Okay. Okay, you have to write to isoelectronic of chloride ion. Isoelectronic. Same number of electrons with chloride. Chlorine 70 electron. So when it become chloride, it become 18 electrons, because it gain 1 electrons. One negative charge means it gain 1 electrons. Okay, now 18 electrons. So you have to write an ions that will be 18 electrons from period 3. These elements from period 3, these elements, sodium, magnesium, aluminum, silicon, these are period 3 elements. So you have to write in ions which will be period 3 isoelectronic with chloride ion, but it have to period 3 these elements. So how it will be 18 electrons? Sulfur, we know how many electrons? Sulfur atom. Sulfur atom, how many electrons? Hello student, are you listening me? Sulfur sulfur, how many electrons carry? Sulfur carries how many electrons? Sulfur.
16.
Yes, 16. For
It would gain 2 electrons.
so silicon 14. Okay, so if I write this sulfur is 16, if I write sulfur 2 minus, so that it become 18 electrons, gain 2 electrons. So this ion is the isoelectronic of chloride ions, and also from period 3. Okay, have you understood? We can write phosphorus. Phosphorus, how can we write? Phosphorus also can be write. What will be charge? What will be charge for phosphorus? It must
-3.
3 minus. Good. 3 minus. So now it 18 electron. You know phosphorus is 15 electron. It 3 minus, right? If I write this thing, that means lost 3 electrons. It will be 15 plus 3 for 12 electrons. Okay, we should give this minus. Okay, so I can write this one or this one, any. S2 minus or P3 minus. This is the isoelectronic of chloride ion from period 3. Okay, these two are correct. Any one you can write. Give the formula of an ion. So one ion you can give anyone. Okay, next question thinks, how does ionic radius and ionic charge affect the strength of ionic bonding? So ionic radius, it decreases if ionic radius, ionic charge increases or the ionic radius decreases, the charge density increases. If the charge density increases, it increases the strength of the ionic bond. If charge density increases, it increases the strength of ionic bond. Charge density. So which have more strong ionic bond? Like I do this sodium chloride and magnesium chloride. This here have 2 ionic bond contain. Why these 2 elements contain ionic bond? Why these 2 elements contain ionic bond? because this is the positive charge and negative charge. When two positive and negative charge atom interact, from ionic bond, and covalent bond form between these are, sorry, metal non-metal, metal and non-metal, between metal and non-metal, ionic bond. So this two is metal and non-metal, metal and, so these two substance contain ionic bonding. Okay, I have noticed this question. When non-metal non-metal, covalent bonding, when metal metal, metallic bonding, here metal and non-metal, ionic bonding. Okay, which compound contain more strength in ionic bonding? More strength in ionic bonding? In ionic bonding, I have given two compound. Have you seen sodium chloride and magnesium chloride, which have more ionic bonding? This is the chlorine is same, chloride same, so this is not factor is the sodium. It is sodium 1 positive charge and magnesium is 2 positive charge. So this the which have more charges, more positive charges is magnesium. So more positive charges magnesium, so attraction, so attraction is more attraction in here magnesium chloride, more charges in magnesium 2 plus ion, so in magnesium chloride is more attraction, so it has more strength. Okay, more strength is magnesium chloride than sodium chloride. Have you understood? Hello student.
Yes, sir.
Okay, which one is more strength, more strong, stronger, sorry, which one is stronger? Sodium chloride stronger ionic bonding contain, and aluminum chloride stronger ionic bond contain. Stronger ionic bond contain, which compounds contain stronger ionic bond? This one, sodium chloride or aluminum chloride?
Sodium chloride.
No, this is the 1 positive charge. Here is a 3 positive charge. Here aluminum is same, chloride is same, so this is not factor. Sodium sodium and positive cation is factor here. Here anion is same, so no, here I don't compare with anion. Sodium and aluminum. Sodium is 1 positive charge, aluminum has 3 positive charge. So okay, so it has more positive charge, so more strength. The ionic charge increases, the charge density increases, the increases the strength of ionic bond. Okay. Okay, what is the trend in ionic radius for set of isoelectronic species from N3 minus to aluminum 3? So these are isoelectronic. What is happen here? Charge increases, nuclear charge increases, aluminum N3 minus, tarpore oxygen 2 minus, then oxygen 2 minus, oxygen 2 minus, and oxygen fluorine 1 minus, helium 0, then sodium 1 plus, magnesium 2 plus, aluminum 3 plus. This the N3 minus to Al 3 plus. Here nuclear charge increases, the number electron remains same. 10 minutes remaining. So nuclear attraction increases, ionic radius decreases. Nuclear attraction increases, so what will be the ionic radius? Ionic radius will increase or decreases from N3 to Al plus.
Decreases.
Yes. Why? from N3 minus to Al 3 plus. Ionic radius increases, decreases. Why? Because nuclear charge increases from so ionic radius decreases. Nuclear charge increases, more attraction force increases, so nuclear charge radius decreases. Is there Maronis is listening me? Hello?
Yes, sir.
Okay. Now this next topic is polarization. Polarization means distortion of ions. Polarization of an ion is the distortion of its electron cloud. Distortion, like positive nucleus, this is the negative. By the influence of positive ions, the charged electron cloud of negative ions, distortion occur. Like it become this way, it was this shape due to the ions of others ions, positive ions, its electron cloud damage becomes what becomes damages, or it is not its actual position, so it is distort. So distortion occur due to the positive ions of to the negative ions is called polarization. So here is a cation and anion. Thus now cation become anion become distortion occur. Electron clouds of the here in uniform, cation electron cloud are same and same. Due to the cation next position, anion electron clouds distortion occur. This is called polarization. So polarization of an ion is the distortion of its electron cloud. So who will polarize? Cation will distort an ion. Cation distort an ion. Cation polarizing power. Which have polarizing power? Cation. Cation have polarizing power. Which one is polarizable? Anion is polarizable. So polarizing power, which cation has polarizing power. Which one is polarizable? Anion is polarizable. Which ion will distort an ion? Ion. A cation will distort an anion. So okay, polarizing power has positive ions, cation. So what is polarizing power? The ability of positive ions to distort the electron density of neighboring negative ion is called polarizing. So what is power? Polarizing is the ability of positive ion to distort negative ions. So polarizing power, polarization. Polarization will increase by high charge and small charge of cation. So if we see the polarization power, which high charge and small size of the cation have more polarization increases because high charge density of the cation, and high charge and large size of the anion. If we see the high charge and large size of the anion and high charge and small size of the cation, polarization increase. So high charge is increases, so we have find here high charge increases polarization, small size of the cation increases polarization, large size of the anion increases polarization. So which have okay, what does polarizing power of a cation depend on? It depend upon the polarizing power of cation it depend upon its charge density, which relies upon the charge and ionic radius. The greater the charge density, the greater the polarizing power of the cation. Greater the charge density, the greater the polarizing power of the cation. Okay, so which cation have more polarizing power? Sodium ion, aluminum ion. Which compound, which ion have more polarizing power? Sodium ion or aluminum ion? Hello student, are you listening me? Which sodium ion, between sodium ion and aluminum ion, which have the more polarizing power? Which cation have the more polarizing power? Huh? Okay, this is the question here. Which sodium ion and aluminum ion, which have more polarized? These two cations, sodium ion cation, aluminum. Yes, aluminum ion has more polarization power, because the greater the charge density, the greater the polarizing power of the cation. Okay, because the greater the charge density of aluminum, so the greater the polarizing power of the aluminum than sodium. Okay, this is the compound. Which of the following compounds has most polarized anion? Anion will be most polarized. Oxygen, magnesium oxide, potassium oxide, and calcium oxide. So which which one is which of the following compound has most polarized anion? Anion will be most polarized by cation. Which cation will be most polarized? Anion. Which compounds? Sodium, magnesium, potassium, calcium. At first you will see check which have more size cation. Here anion is same, so no problem. We will compare with magnesium cation. Which cation has small size? Small size cation. This is the cation magnesium, potassium, and calcium is more size. They are pure 3. So we will cut this one at first. We will not compare these things. Okay. We will find the small charge cation. Okay. So these are two small charge cation, sodium oxide and magnesium oxide. Now these are small charge, but which have more charge? Small size. At first we compare size. This has small size, these two more size. So more size I will nullify or don't compare. So we know small size cation has more polarizing power, and anion become more polarized. So these two sodium and magnesium have more polarizing power. So they are polarized more, these two anion, oxygen. And now these are smaller. Now we compare charge. Which one has more charge? Sodium and magnesium. Which one has more charge? Magnesium has more charge. So magnesium will more polarized than sodium.